slides today. You know, sometimes I say PowerPoint, was it power corrupts and PowerPoint corrupts absolutely. So instead, I'd much rather have a discussion with you this morning because I'm very concerned about getting the interplanetary network off the ground, so to speak. There are people sitting in the room who have been working on this since 1998 and have had a great deal to do with making this happen. I think of Scott Burley and Keith Scott, for example. So, David and all the other folks. So, what has happened so far is that NASA has been kind of slow at picking up this technology and really running hard with it. There's an organization at the Jet Propulsion Lab that manages the Deep Space Network, which some of you will recall was built in 1964. You can imagine that it's now 50 years since that time. The equipment is old. These are 70-meter dishes in 3 places around the world. There are additional smaller size dishes that are available, but they haven't been building a whole lot more of them. So we have this fairly old infrastructure, and the parties who are responsible for that have the problem that they have to keep maintaining the equipment and don't seem to be able to put in additional ground capability. It's my personal belief that we should be advocating for an end-to-end infrastructure, which means that for space exploration, we should be providing off-the-shelf capability for the interplanetary protocols, the DTN protocols, available for both spacecraft and ground use. And I'm happy to say that Boeing has stepped up pretty smartly I mean that in both senses of the word, to pursue that. To be honest, I also hope that others, like Lockheed Martin and Ball, that make these spacecraft will also pick up on this idea and have these kinds of capabilities available off the shelf. So it's been a long slog since 1998. On the other hand, the availability of the software has improved dramatically, especially now that we have this software available at SourceForge, for instance, the ION software that Scott Burley does, and the DTN2 software from, I guess it's still BB&N. We have other implementations that have been done for Android operating systems or for Chrome, and even for some of these small devices like the Raspberry Pi. And that leads to something that Mike alluded to, which is getting young people interested in using these kinds of protocols. The maker movement is an obvious place to pursue that. Just to pick up on the offer that Mike made, there's a group here in this area called Nova Labs for Northern Virginia Labs, and it's got about 16,000 square feet of space, and several thousand kids have gone through this program using equipment like the Raspberry Pi or some of the other related things to build devices that you can operate remotely and program. They also have a wonderful program for young girls. They bring them in and let them take printers apart. And the whole idea is twofold. One, get them comfortable taking stuff apart, and then harvesting the pieces they can use for something else. And so what they've been doing recently is taking apart the printers, harvesting the little motors, and then building 3D printers, using 3D printers to print the parts that they can't get out of the printer. And then so it's sort of like the Sorcerer's Apprentice thing, because they keep, cranking out these 3D printers. So the idea here is to get kids interested in actually making something work and, turning things into reality. And so I like that a lot. And I think that our challenge, to the extent that we're interested in serious expansion of communications capability for space exploration, is to demonstrate its utility on a more consistent and regular basis. So what I wanted to do this morning, frankly, I don't quite know how we're going to handle the logistics of it, is to just ask you to think about how we can make visible and maybe even make more imperative the design and implementation of an interplanetary backbone network. It's not that anyone thinks that you should just build this gigantic interplanetary thing and then hope that somebody uses it. The theory has been that by standardizing on the protocols, that every spacecraft that is built by any spacefaring country could ingest those protocols and have them available either to support the scientific mission that the spacecraft is designed for, or to be applied after the spacecraft has completed its primary mission, and then serve as a node in an interplanetary backbone. So my interest right now is in taking people like you who are interested in this, I hope anyway, and I assume are interested in this, and see whether we can harvest some ideas for stimulating not just NASA, but possibly the other companies that are starting to get interested in this. I mean, we have the traditional spacecraft makers. Oh, and we even have wireless microphones, even better. So I'll stay here. Or I may just run around with a microphone, which is better for me. So if you don't mind, I'll do that. That's part of my exercise program. Anyway, there are new space companies, as you know. I mean, there's Orbital Systems and there's SpaceX, just to name two. Virgin Galactic, we want to test and see if it works. Testing. Yes, that works. Ta-da. But you have to hold it up to your left nostril.
Yes.
Is it audible all the way in the back? Okay. What is it? The usual question is, can you hear me back there in the rear? And the answer is no, we ain't built that way. Sorry. So there are these new companies that have come along, and I don't think that they are yet fully exposed to the idea of using a new set of protocols other than TCP/IP for communications in their applications. And there's a reason for that. A lot of those systems are near-Earth kinds of systems. Some of them are constellations of satellites, or that are planned constellations. Some of them in large numbers, like in the thousands of satellites in orbit. At Google, we've been working on using balloons for that purpose. It's called Project Loon because it's a little loony. The balloons are at about 60,000 feet, and we've got them to last long enough that they've actually circled the Earth multiple times in the same latitude, radiating Wi-Fi downward. So I'm interested in your ideas for drawing attention to the utility of these protocols, both for terrestrial applications, but even more importantly for interplanetary exploration. So I'm going to run around and hope that somebody has some ideas about what else we can do beyond what we've already done. I do need to cite the hard work that Keith Scott and Scott Burley and others have done to get these protocols into standardization in the Consultative Committee on Space Data Systems. And maybe, Keith, you could say a little bit about where we are with that at this point. Because it seems like we're getting close to a full suite of protocol standards. Is that correct?
So not full suite, but we have gotten now the Collider Transmission Protocol, so essentially a reliable data link layer on top of other CCSDS space links, is now actually all the way through standardization in CCSDS. It's going to get published soon. The document editors make the final pass through that. And the CCSDS protocol, the CCSDS profile bundle protocol is essentially completely done. We've done all of the specification and the required interoperability testing, and we just need to file the interoperability test report and get that through. So we have essentially the sort of the moral equivalent of IP and a reliable link layer now standardized within CCSDS. But what we don't have is any of the other infrastructure that lives around that. So we don't have standards for, say, routing or network management or key distribution.
Is there anything in the pipeline for that purpose? Or
Yeah.
is this, okay.
Oh, yeah.
So this isn't, it's not like there's nothing, it's more like it just isn't all the way through the pipeline.
Correct.
So let me ask David the question. What about the TDRS, which has served NASA and others for quite a long time? There are upgrades that are either planned or in the works. Is there anything related to the DTM protocols that you could say something about?
Yes, so TDRS, the current TDRS is an RF bent pipe design. So we've done demonstrations of flowing DTN by having bundle agents on ground, and you'll hear about today's space station where they're doing DTN, and actually goes through TDRS. During my talk this morning, I'll talk about the recent study on the next generation where DTN is a part of it. And we're working how to apply DTN in this nearer point of view. Okay.
Can you say, I don't need to take away from your talk, maybe you'll answer this in your talk, and you don't need to answer. Standing under the microphone is causing, under the speaker. How's that? Wow, this is weird. This probably means I'm infectious and I should stay back or something. Is it the case that there would be a useful plan to put ground station capability near a TDRS uplink so that you could relay information coming from some other TDRS reachable point into the rest of the internet, for example?
So yes, the idea is that you'd be able to network both through TDRS or whatever the next generation relay is, and that network would be tied together to commercial networks or other networks together and interact.
So you also have a ground station or something in Antarctica, if I remember correctly. I have an interest in that too, with another hat on the National Science Board. And it turns out that we have some very expensive facilities in Antarctica near the South Pole, specifically the Ice Cube, which is looking for high-power gamma rays. Just to show you that physicists have a sense of humor, some of the higher power detections, like up in the, I don't know what the right numbers are, 13 giga-electron volts, were named Bert and Ernie. And then another one came along at 28 GeV, and they called that one Big Bird. And I haven't heard about any others, so hopefully don't run out of names before they run out of detections. But having that capability in Antarctica would make a big difference for NSF as well. What about commercial services? We watched SpaceX launching things up to the space station. They launched and demonstrated a crew capsule, for example, that lands, in theory, lands on its tail. Are there other commercial enterprises that any of you know about, I'm picking on Dave, just for convenience, that could be persuaded that having DTN ground stations and space capacity would be useful to them?
So, I believe so, and today is actually my start to try and make the case. And so actually the South Pole communicates through TDRS now, and we first put it in when they were bringing the previous neutrino detector, Amanda, was there, and that was actually when we first tied the IP over the NASA network then. So what they do now is an application that I'd like to get DTN in use for that, because we put in a system in 1997 that they accumulate the data files at the South Pole. When the TDRS was far enough south in its figure eight progression, then the link would come up. In the beginning, it was just 2 hours a day, and then the computer at the South Pole would be able to talk to a computer at White Sands, and an automatic file transfer would happen. We're already talking about putting in the DTN demonstration from Alberta.
I'm scheduled to go to the South Pole, not this November, but next November, so I'll be looking forward to trying that out when I get down there. What about other, I've talked to Elon Musk's engineers at SpaceX, and at the moment they are pretty concentrated on a constellation of medium or low to medium Earth orbit satellites, which probably are not, they're going to be sufficiently connected that DTN may not necessarily be an issue for them, although they do have an intent to storm forward through satellite in order to get to the ground. But I'd be interested to know if anyone else has some ideas of what's going on in the industry that we might want to approach to urge them to implement these protocols. Anybody else has some ideas? Yes, sir. You might introduce yourself in the process.
Sure, I'm Bert Loman. I work in the International Space Station program. Do have one thought, I don't know where to take it, is I work with some payloads that go to ISS, and some of them are robotic payloads. And there was one robotic payload, I won't call them out, but they're using a protocol called DDS. And they tell me that it's a military protocol. It's actually a protocol that you can buy from a company, and it helps them do some of the things that DTN does. Now, I thought maybe it might be beneficial to be talking to maybe some other competing or tangentially competing protocols, and we were asking them if they could be using DTN to help facilitate that DTN growth.
So, are you free to share with us the specific protocols they're using now, and maybe even who we should be talking to? Are you allowed to do
I
that?
can certainly discuss offline who I was talking to about it. And I mentioned DTN, and they said they're going to look at DTN. The protocol was what he described it was called DDS. And I went and looked it up, and it's a whole suite of protocols beneath that. But there's an overarching layer. It's a bunch of middleware software that I thought that DTN could be applied to, as if that company wanted to pursue that. Right?
Thank you. I'm looking for more ideas like that. That's a good one. Anything else? Yes, sir.
I'm Fred Temple with Boeing. We have, over the course of the last several months, gotten a IETF working group stood up for DTN. And with the IETF, we have an international community coming on board and getting involved in the discussions. So we actually have some colleagues from Airbus that are getting interested in DTN. And a lot of the applications have to do with like mobile ad hoc networks. What happens when you don't have a continuous link on a battlefield or something like that. So we're seeing a lot of folks from the IETF community get interested in DTN and starting to sign up to write documents for the IETF.
That can actually help quite a bit because we have RFCs that have come out, and of course we have the CCSDS work that Keith mentioned. The thing that we don't necessarily have is internet standards for these things because they came out of the Internet Research Task Force. So the IETF working group would make a big difference in terms of visibility and acceptability of the protocols in that community. So I'm glad to know that that's underway. Are there other opportunities that you guys know about? Maybe not. What do we do about following problem then? I'm looking at the space applications. A lot of those applications have channels available that are kind of schedulable because they're based on orbital dynamics. And so we can have sort of a planned connectivity because we know something about where things are and when they can possibly communicate. But I'm thinking about terrestrial applications where you don't really, when you are connected, you don't necessarily have a really good solid connection. Mobiles tend to have that problem. You have in military applications, not only do you have connectivity problems that might be just related to geography, but you also have active jamming and other kinds of effects. And so the links that you get when you get them are not necessarily very good. And I'm starting to worry about what happens when you can't actually transmit a whole bundle. What are we supposed to do? Now, there should be a fragmentation capability, right? That there still is one. But that leads to the need to reassemble a fragment. And there's no guarantee that all fragments will follow the same paths. We've all been here before. This is part of the internet world as well. And in the early ARPANET design, we ran into something called reassembly lockup. This is where a whole bunch of partial packets were assembled at the destination, and then they ran out of memory space, but nothing was fully assembled. And so any new packet that showed up had to be thrown away because there was no place to put it. And so you just got into this lockup condition. That's why there was an RFC that said, fragmentation considered dangerous. On the other hand, we're going to be faced, I think, in terrestrial applications with exactly this problem. The packet size is not properly suited to the flakiness of the channel. In the internet world, we have this MTU path discovery idea, but I'm less comfortable with that in the DTN protocols because I don't know how reliably you do MTU discovery given the potential flakiness of the channel. This is probably not the right place to go dive deep into this, but it suggests to me there's still a lot of work to be done for particularly lossy channels in this internet and interplanetary or DTN environment. So is it fair to say that the IETF working group could potentially tackle things like that?
Can I switch the mic here real quick?
Oh, sorry. Thank you.
Thank you.
It
It was just not connected to the live stream, but yeah, let's go.
The IETF working group, I think, is open for bringing new items into the working group charter, but that would have to go through the IESG now to bring in new items. But fragmentation and PathMTU discovery obviously are very much related to how much time of a contact you have. So it's time. How much time on the wire does it take to transmit a certain quantity of data? But that's certainly an item that we could bring into the discussions in the IETF to consider to have brought into the agenda, to the working group milestones.
Scott?
And just to go back to the earlier point about the fragmentation being part of the specifications, there's been some discussion of how do you preserve fragmentation. Is reactive fragmentation still a good idea? These are certainly active topics of conversation in the working group. One thing I wanted to bring out was that to some extent the fragmentation lockup problem, I think, is less of an issue now than it would have been 25, 30 years ago, because storage is so cheap. Bandwidth has not gotten that much cheaper, but storage has gotten way, way cheaper. So I think we're much less constrained by that, even on spacecraft, even on flight missions, than we have been in the past. So I think there are still plenty of issues in getting fragmentation right, but I think we're in a stronger position working on it than we have been earlier.
I should finish up soon, yes? Oh, no, you want it in. All right, here we go.
Two items. One is, Brett, we talked earlier and you didn't think you needed the full hour. Can we poach 15 minutes from your present? Okay, great. So you have more time, Vint. This is being webcast, and there is a question from the webcast. This is from Eleni Penagau in Greece, and she says, hello, Mr. Vint Cerf. Is the interplanetary connection per se the main aim of IP and ISOC, or could it be the transformation of the existing internet to a smarter one? Greetings from Greece.
Gee, we were all pretty happy with the stupid network, right? I mean, the whole idea was David Eisenberg was the rise of the stupid network. It was the reason it was so flexible is it wasn't designed to do anything in particular, and so it did everything moderately well, but nothing spectacularly well. And as it got faster, we made it do more and more things. So I don't necessarily see this as embedding down in the guts of the internet necessarily. DTN is an overlay network, so it runs over pretty much anything. Well, something that David just said earlier kind of struck me as interestingly odd, and that's running IP over DTN. You're not doing that? Oh, okay. There are some people who would like to do that. And there's Scott. Okay, yes, Scott?
There actually are a couple of implementations of that already, and it is useful, at the very least, it is useful as a transitional kind of thing, because it's one of the major obstacles to infusing DTN in operations anywhere is having to rewrite your applications to use DTN instead of write to sockets. If you can put DTN underneath the sockets, they don't have to touch anything, and automatically you've DTNized the applications, provided they're not TCP. If they're UDP, then you can do it. If they're TCP, it doesn't work all that. It works somewhat, but it doesn't work as great. But it is a useful thing.
So this just proves that my T-shirt must be right. It said IP on everything, and that's apparently what's happening. I did have a related point to make, and that has to do with another potential demand for DTN. I was on the phone with a guy from the Consumer Electronics Association that puts on the Consumer Electronics Show every year, and he has an IPv6 working group, and they're focused on, of course, the Internet of Things. And Internet of Things is an interesting concept because a lot of the things, first of all, they have processing capability because they have software, and as Scott points out, some of them have fairly significant capacity because memory is so inexpensive. But they also are often running on batteries. And so the consequence of this is that they want to be very careful about how much energy they use up, which means that they may not be on all the time. It may mean they only turn on at certain times to either transmit or receive data, accept control, and things like that, which DTN is very well suited to support. And so, although I've not seen an initiative along these lines, it's possible that in consequence of today's meeting that we should think about DTN as a possible Internet of Things tool to help deal with this episodic connectivity or sporadic connectivity. Now, there's one other thing, Scott, that your comment about memory is cheap makes me think of. Is everybody here familiar with the buffer bloat problem? Does that ring a bell? For several people know about that. So there is a kind of interesting issue. Imagine that you're a DTN relay, and you have a lot of memory, and you're filling up with a lot of bundles that must still be delivered. And we could easily understand that the data rates available to that node may vary depending on which direction you're going in and where. So there's a possibility of a mismatch in the data rates that are available, or the transport rates, in which case you could imagine filling up a lot of the buffer. Now, what Van Jacobson and Kathy Nichols have come up with is called FQ CODEL. I think they've had fair queuing, and I forget what the CODEL actually stands for, but it's an attempt to adjust the size of the buffer, in this case typically in a home router, for instance, to adapt to the fact that you have potentially high-speed and low-speed channels, and in the low-speed direction you may build a giant buffer that creates huge delay, in which case TCP times out and starts retransmitting and you get congestion. I wonder whether there is an analog that we should be worried about in the case of DTN. We do have things that say this bundle is not worth sending anymore. There's a possible timeout. But that may be a very crude kind of congestion control mechanism. And it's hard, for me anyway, it's very hard to think about DTN and try to forget about all the things we learned about more or less continuous connectivity and rapid pinging round trip, low delay round trip. Trying to find out what's the state of affairs in a DTN network turns out to be hard because you can never quite tell when you're going to find out what the state actually is. So I don't mean to pick on Scott necessarily, but you clearly brought this up unintentionally. So I'll offer you an opportunity to respond.
Right. So that's congestion control in DTN has been a challenge for a long time. So what we started doing in the ion distribution many years ago is building routing off the contact plan, because we know what the planned contacts are. And since we've got that contact plan, that's actually our information about the network, so we can do a congestion forecast based on the contact plan, because we know the rates going in, the rates going out, and we can impose the rate control to make sure you don't get into that problem. What the forecast will do is, if it detects that there is an imbalance, it'll report the imbalance so that somebody whose job it is to manage the network will make the adjustments and fix it. What we've started looking at lately as to sort of take that closer to being automated. Several years ago, a guy from Democritus University of Thrace came to JPL to do some work for a few months, and we worked together to develop a bundle delivery time estimation algorithm, so that you could estimate what's the 99% chance that this bundle, at what time will there be a 99% chance that this bundle will have arrived. You can imagine using that number not just to give mission operators a warm feeling about when the data is going to come in, but also as a way of estimating what your time to live should be. So if you estimate the highest probability delivery time and add 20% to it, set that to your time to live, suddenly you've got a non-conversational congestion management system. So that's something that I'll mention later on when I'm talking. But I think it's the kind of thing that we can do, given a contact plan in the network, even if the contact plan is not absolutely certain. And that's another dimension that we're working toward with the ION implementation is is probabilistic contact plans.
Over time here, so I just have one last point. I want to bring this back. I've been talking terrestrial, for example. I want to bring this back now to the interplanetary environment. Do you suppose that it would be beneficial to start laying out some example mission profiles that would involve multiple orbiters, multiple ground stations, or mobile vehicles, and so on, in order to demonstrate the need for this kind of networking capability? Because a lot of people in the scientific community are very focused on a particular instrumentation package on one spacecraft, and their model of the world is, I need to talk to it and get data back, end of story, and don't bother me with anything else. And my worry is that this is not broad enough thinking. It's also mission by mission thinking. And infrastructure and mission by mission thinking are sometimes at odds with each other. The infrastructure should be there for multiple missions. And so I think the DTN environment is important in that regard, because if we implement it in the right places and are consistent about maintenance and sort of sustainability, then that infrastructure will serve for a long period of time, potentially, just as the Deep Space Network has for over 50 years. And I'm concerned that I have not made that argument adequately. And so I'm very interested in trying to figure out in what venue would it, if you agree that we should be making arguments along these lines, painting scenarios that are credible, in what venue should we be making that argument? You know, where do we publish? Where do we speak? Whose ear do we grab in order to incite that? And is it the scientists that we need to talk to as opposed to the engineers?
So my answer is actually against what you suggest. Yes, because so this is what I've seen, and maybe these guys will back me up on this, but you're not required to. Okay, but within NASA and the CCSDS and the international community, what I've seen happen with DTN is that we do have these pictures and these scenarios of, 10 years ago it was like all the things on the lunar surface need to talk to each other, or there's going to be all these things at Mars that need to talk to each other. And what I've seen actually happen is that people say, well, we have a long time until that happens, or we'll never get those many nodes. So I've felt that it's been so tied to those scenarios that it's given people an excuse to just kind of keep pushing it down the road. So what I believe and what I'm working on is making the case for why we should be using it now for the near Earth, the LEO missions. I think you can make the case. The space station is making the case, and we can start to implement it, and then we know from the technical work that it will apply to those interplanetary missions. But to use those as the reason for why we're doing it, I think has led to the delays.
So thank you. I mean, that's exactly why we're having this discussion. I think some of us have encountered exactly the situation where it's not the large numbers that count. The situation with the rovers on Mars, I think, was a pretty concrete example of that, where the relay turned out to be a big solution to a tough problem, which was direct to Earth not working very well. And so the store and forward gave us 4 times as much data, and reliably, because all the data that's come back has come through that path.
What they'll tell you is that they didn't need DTN in order to do that, and it already is working, right? So that's sort of the trouble that we're up against.
Yes, except the counter to that is that they did a one-off. And why do you want to keep doing one-offs if you could do something that you could apply on a repeated basis whenever issues like that arise? So, and having it built into the system as part of the standard complement of software and communications seems to me like the better infrastructure. Anyway, I think I've run out of my time here, but I thank you all very much for sharing some of your ideas. I hope in the course of the day we'll encounter other opportunities to make the case that DTN is really important, not only for terrestrial applications, but for space exploration as well.